The Cold War converted airspace into an intelligence domain, where nuclear uncertainty made ignorance dangerous and diplomacy insufficient. Observation promised certainty, yet visibility invited retaliation, forcing aircraft into a role of restraint and risk. The RB-29 Superfortress addressed strategic ignorance by adapting a bomber into photographic reconnaissance, relying on altitude and range to penetrate airspace, but its size and vulnerability exposed crews and signaled escalation, driving demand for safer methods. The Tu-4R Bull mirrored that need on the Soviet side, using reverse-engineered range and cameras to map adversaries. Yet bomber-like profiles limited survivability and deniability, pressing both blocks toward platforms that could see without being seen. That dilemma soon met early reconnaissance limits. Early intelligence flights leaned on modified World War II bombers, trading subtlety for reach. Range increased, but safety diminished as air defenses improved, turning routine collection into political wagers. Detection meant escalation, and escalation narrowed strategic choice for both blocks. The RB-50 Superfortress sought to fill electronic blind spots by hauling receivers and cameras over long distances, using endurance and payload to harvest emissions, but its slow speed and conspicuous radar signature left it exposed, pushing planners toward altitude-based survival. The Tu-16R Badger addressed similar gaps for the Soviet Union, employing range and maritime sensors to map fleets and radars, yet its bomber-derived profile invited interception and diplomatic fallout, pressuring designers to escape bomber compromises. What followed was a recognition that endurance alone could not buy security. Survivability would require altitude, not merely persistence. The next response was vertical rather than lateral. Height delayed danger, but did not remove it, and altitude was treated as insulation against interception. Designers stripped aircraft to essentials, exchanging speed, payload, and redundancy for ceiling. The Lockheed U-2 was built to solve denied area visibility by flying above fighters and early missiles, using extreme altitude and long-endurance cameras. But fragility, slow transit, and reliance on overflight permissions exposed political risk, signaling that altitude alone was temporary. The Myasishchev M55 pursued a parallel logic for the Soviet Union, exploiting lightweight structure and high ceiling to study reconnaissance concepts, yet limited payload and defensive weakness confined it to niche roles, reinforcing the same vulnerability. For a brief period, intelligence dominance returned from above. That sense of safety proved misleading because defenses would evolve upward as well, with missiles and radars reshaping the altitude equation permanently across theaters. By 1960, information gained openly carried hidden costs. Altitude-based confidence collapsed when a surface-to-air missile reached where planners assumed immunity, converting reconnaissance into crisis. The SA-2 guideline system was designed to solve high-altitude denial, using radar-guided missiles to extend defensive reach vertically. But early accuracy limits required favorable conditions, driving iterative improvements and broader air defense networks. The Lockheed U-2C sought to preserve overflight intelligence through incremental altitude and sensor upgrades, relying on height and endurance. Yet its slow speed and political exposure left no margin once defenses adapted, forcing reconsideration of the entire approach. The shoot-down detonated diplomacy as effectively as it destroyed an aircraft. Intelligence collection remained mandatory, but deniability evaporated, and acceptable risk narrowed sharply. What followed was not restraint but redirection, as planners searched for methods that could outrun consequences rather than merely rise above them under Cold War pressure and constant strategic scrutiny from rival nuclear powers globally. The failure of altitude shifted emphasis toward velocity. Faster flights solved interception, not endurance, and speed was treated as evasion rather than concealment. The Lockheed A-12 was designed to penetrate denied airspace by outrunning fighters and missiles, using sustained Mach 3 speed and high altitude with advanced sensors. But extreme heat, maintenance burden, and narrow mission profiles drove costs and limited sortie rates, signaling fragility. The MiG-25RB Foxbat answered similar pressures by combining raw speed and altitude for reconnaissance and strike, relying on brute performance to evade threats, yet fuel consumption, sensor limits, and pilot workload constrained persistence, revealing the same trade-off. Speed reduced vulnerability without reducing exposure. Aircraft survived by outrunning consequences, not avoiding detection. That solution proved technically impressive but operationally brittle, as extreme performance strained budgets, logistics, and airframes, creating sustainability problems that pointed toward endurance and invisibility rather than acceleration. As defenses matured, signals replaced images, but ambiguity increased. Intelligence priorities shifted from visual confirmation to mapping emissions, allowing observation without violation. The RC-135 rivet joint addressed escalation risk by collecting radar and communications from international airspace, using endurance and sensor fusion to build electronic order of battle, but reliance on interpretation and permissive access limited certainty, pushing refinement. The Tu-95RTs. Bear-D pursued parallel goals for the Soviet Union, exploiting long-range and powerful receivers to cue fleets and missiles, yet its large signature and dependence on continuous transmission constrained survivability, encouraging quieter methods. Electronic intelligence reduced immediate confrontation while expanding strategic awareness. It traded clarity for deniability, replacing photographs with probabilities. Competition persisted beneath restraint as both sides raced to interpret signals faster and more accurately. Reduced risk did not mean reduced rivalry. It merely shifted conflict into spectra and code, setting conditions for platforms that could listen longer without being noticed globally. Shared intelligence reduced exposure, not rivalry. Surveillance expanded outward as allies assumed roles along borders and sea lanes, extending reach while diluting political blame. The Canberra PR-9 was designed to monitor contested regions without superpower markings, using high altitude and photographic sensors to gather strategic imagery. But limited self-defense and reliance on access corridors constrained missions, pressing cooperation. The RF-104G Starfighter addressed fast reaction reconnaissance for NATO by combining interceptor speed with tactical cameras, relying on dash speed and low exposure time, yet short-range and payload-restricted coverage, reinforcing networked sharing. Allied flights multiplied coverage without multiplying crises. Intelligence moved through agreements rather than declarations, spreading risk across flags and commands. Yet peripheral surveillance remained fragmented, strongest near borders and weakest over open water. Cooperation mitigated escalation but preserved competition, leaving maritime spaces comparatively thinly observed. Those gaps would soon demand platforms able to watch oceans continuously, beyond national airspace. Observation at sea blurred peace and prelude. Naval competition required constant awareness of fleets, submarines, and missile activity, pushing reconnaissance closer to armed forces during crises. The EP-3E Ares was built to track maritime signals and missile-related emissions, using long endurance and dense sensor arrays to monitor fleets and tests, but slow speed and proximity to hostile airspace exposed crews, intensifying escalation risk. The Il-38 May fulfilled similar Soviet needs. By combining patrol endurance with acoustic and electronic sensors to watch carriers and submarines, yet limited sensors and defensive vulnerability restricted persistence near contested zones, pressing diversification. Maritime surveillance created a second stakes spike. Intelligence aircraft now operated where miscalculation could trigger immediate response, not delayed protest. Observation supported deterrence while resembling preparation. As patrols lengthened, basing and logistics became strategic constraints. Persistent coverage could not rely solely on distant airfields, pointing toward platforms and concepts able to remain on station longer, closer, and with reduced political visibility globally today. Safety improved while clarity narrowed. Late Cold War reconnaissance shifted outward, emphasizing distance, automation, and continuous sensing over penetration. The E-8J STARS was designed to monitor ground forces from standoff ranges, using radar and data fusion to track movement without overflight, but limited resolution and dependence on uncontested airspace constrained precision, driving complementary systems. The Tu-214R addressed similar requirements by integrating advanced electronic and imagery sensors for wide area collection, relying on standoff endurance and processing power, yet reduced immediacy and classification limits, narrowed tactical detail, pushing further automation. Standoff collection traded intimacy for persistence. Intelligence became less about single decisive images and more about patterns accumulated over time. Human risk declined as crews moved farther from threat envelopes, but interpretation burdens grew. These systems stabilized competition without resolving uncertainty, setting conditions for platforms where automation could persist without crews at all during late competition. Secrecy prevented war while ensuring perpetual suspicion. Cold War reconnaissance normalized constant observation as a substitute for open conflict, embedding surveillance into stability. The SR-71 Blackbird represented the apex of manned penetration, designed to solve denied area intelligence through extreme speed and altitude, using velocity and sensors to evade defenses. But immense cost and logistical strain limited availability, pointing toward unmanned persistence. The RQ-4 Global Hawk addressed endurance and political risk by removing pilots, using high-altitude, long-duration flight and automation to collect broadly, yet reduced responsiveness and vulnerability to modern defenses, narrowed certainty, echoing earlier trade-offs. Each generation solved one problem while exposing another. Altitude, speed, electronics, and distance traded risk without eliminating it. The intelligence war above borders reshaped restraint itself, making surveillance routine rather than exceptional. Methods changed across decades, but the logic endured. Security pursued through observation, and peace maintained through managed uncertainty. Under geopolitical competition between rival nuclear states,